Hi, topic for this session is computer memory. As we know, the word memory implies to place where information can be stored for further retrieval whenever required. As it's very essential part of human being, a memory to recall whatever has happened maybe yesterday, right? Similarly, it's important for a computer system also. The main functionality of computer is to store data or information and use it for further processing. So, memory is an essential part of computer system. In computer system, the various units used for measuring storage, space or data are bit, most atomic one that can have two values 1 or 0. Next is nibble. Nibble is consists of 4 bits. So 4 bits is equal to 1 nibble. 8 bits is equal to 1 byte. 1024 bytes is equal to 1 KB. 1024 KB is equal to 1 MB, and 1024 MB is equal to 1 GB or gigabyte. 1024 gigabytes is equal to 1 terabyte, and it goes on. Next we have petabytes and so on. Note, 1 kilobit where B is written in small kb is different from a kb which has capital B, right? 1 kilobit contains 1000 bits, and there are 1000 kilobits in 1 megabit, right? So kilobit are smaller than kilobytes because 1 kilobit is equal to 1 by 8 of 1 kilobyte, right? Or in other words, we can say 1 kilobyte is equal to 8 kilobits, right? So here is the hierarchy for memory. It shows different type of memories that we have in a computer system. Going from bottom to up, the performance of or the speed of the memory accessibility increases. Also, the cost of memory per unit also increases. Higher is the speed of the memory, more costly it will be. Starting from the bottom, we have input output devices that has small amount of buffers within that device for temporary storage, right? May or may not have, it depends. So then we have the main memory. Let's come to the main memory, that is called storage device types. Those are secondary memories. Then we have primary memories. Those are physical RAM and virtual RAMs. Then we have cache, that is at level 1 and 2. Level 1 cache and level 2 cache, L1, L2. There is another cache also called L3 cache. Then we have CPU register which are embedded with the processor, within the processor, right? That actually map up the speed with the CPU, central processing, which is very high speed processors, right? So let's see them one by one. There's another important point is cache and primary memory, RAM, are temporary storage memories, whereas ROM and hard disk, your internet data, your pen drive, those are secondary memory storages, right? Or auxiliary memory storage. So let's start them one by one. CPU registers are top in the hierarchy. That means it has the maximum speed equivalent to 1 clock CPU. So 1 clock of CPU will give 1 clock of registers as well. So it's in sync with the speed of the CPU. CPU internal, high speed CPU internal storage to match with the CPU speed, but are costly as they are have more speed, so they are more costly and consume significant power. So hence number of registers in the processor are too small. If you have seen the processor, there are small chips called registers on that processor. Next in the hierarchy is cache memory. Its storage may be internal or external to CPU. That means it may be integrated with the CPU or the processor, or it may be on the motherboard. It's small size volatile memory. Volatile memory means the data on the memory is lost when the power fails or system is switched off. That small size volatile memory that provides high speed data access to processor to map up the speed of the processor, stores frequently accessed programs and data. Frequently, if we try and access the same program instructions or data after periodic time, so that will be saved for a predefined interval on the cache. So there are three types of cache: L1, L2 and L3. L1 cache is internal and integrated on the CPU. It is the fastest cache whose size is from 8 to 64 kilobytes. L2 cache is a secondary cache that is larger in size but slower than L1, typically ranges from 64 kilobytes to 44 megabytes. L3 cache is an enhanced memory built on motherboard, faster than main memory, that is the next memory in the hierarchy. Right. Then we have main memory. Main storage unit external to CPU, so it has a different slot on the motherboard outside the CPU area. The main storage unit external to CPU or processor, only memory directly accessed by the CPU. So if CPU doesn't get the data from its own registers and cache, so it can request or check the primary memory for data, that is RAM. Okay, to exchange data or instructions to be executed by it, the information is transferred through a bus. There are a series of 8-bit or bus or wires, we can say, that travels from CPU to RAM, through which it's technically called bus, through which the data is and instructions are passed to and from CPU. The primary memory are of two types, RAM and ROM. RAM is random access memory and ROM is read-only memory. Again I repeat, RAM is random access memory and ROM is read-only memory. Right? ROM is a primary memory, but the data stored on is permanent. That's why in the hierarchy, if you do remember, we have put it in the permanent memory category and not in the along with the RAM. Okay. So RAM is a random access memory, or called temporary memory or volatile memory. Why it's called volatile? Because its data is never stored permanently. Right? Data instructions is stored temporarily on it. Data instruction is erased as soon as the power fails or we switch off the computer. Data is loaded from the secondary memory for processing. Now, secondary memory or the auxiliary memory or the permanent memory, that is not directly accessed by the CPU. Never. CPU is never going to take data directly from your hard disk. It will only it will request the data, and primary memory is going to get that data from secondary memory to itself. So CPU is going to access that data from RAM only. Instructions for loading the operating system and other applications are loaded from secondary memory to RAM, and then CPU access from the RAM. There are three types of RAM, that is random access memory: static, dynamic and virtual. Dynamic memory is relatively slower and less costly. It's used mainly for main memory. It only has one register, so the speed is less. Contents are refreshed constantly 1000 times per second, and it may change because the data may be kept for a longer time as no more required, so it may be replaced or removed from the dynamic RAM. Static RAM is comparatively high in speed, thus expensive. It uses 6 registers to store data. It can accept one command and transfer one word of data per clock cycle. Then we have virtual RAM. Now this is very important. Suppose we have a program that is bigger than the size of the RAM, or bigger than the size of RAM available. So it's an area, then we use the part of the hard disk as RAM. That is called virtual RAM. It's an area of system secondary memory storage space such as hard disk or a SSD, solid state drive, which act as if it were a part of the system RAM or the primary memory. Ideally, the data need to run application is stored in RAM, where they are accessed quickly by the CPU. But when the large applications are run, or when many applications are running at once, the system RAM may become full. So then they use virtual RAM for accessibility. For further details, you can go on the link given below. Next is ROM, read-only memory. Data stored in this chip is non-volatile, that is, that is not usually changed. That is, it is not lost when the power is turned off, furnished by the manufacturers regarding this system. It usually has the data written by the manufacturer depending upon this system. So this information can simply be read by the user but cannot add new data, or it cannot be modified. On turn on, the computer loads BIOS, basic input output system, from ROM. Data stored in these chips is either unchangeable or requires a special operations to change it. Applications are video games, calculators, microwave oven, etc. As data stored in advanced type of ROMs can be altered with special skilled operation that we discussed in the previous slide. So there are three advanced type of ROMs. Those are PROM, programmable read-only memory. So anybody who has a skill, special skills, can program this PROM. Erasable, programmable read-only memory. We can erase it, we can program it again and again. Okay. The EEPROM is electrically erasable programmable read-only memory. Data can only be electrically be erased, then can be reprogrammed. Right. So we'll not go in detail of this. If you want to go on more details, you can only refer to the supplements. Next level of memory in the hierarchy is secondary or auxiliary memory. This is very slow and less expansive per unit. Only communicates to CPU through primary memory. It doesn't. So secondary memory or a hard disk or SSD cannot directly communicate to the CPU. It always has to communicate through primary memory. Store and keeps data even when the power fails. This you might have observed. Once the data is kept on the hard disk, it can be secured for maybe 1 year, 2 year, 10 year, till you don't actually go and delete the data. Secondary storage devices are magnetic disk or tape, optical disk, USB flash drives, and mass storage devices. First is magnetic memory. It means tape or disk are non-volatile type of magnetic memories. Magnetic tape consists of thin plastic ribbon, and magnetic disk consists of maybe a plastic or a metal. The magnetic tape is a sequential access memory, so read-write speed is slower. It goes with the sequence. It always cannot jump from one instruction to 15th instruction, so it's a bit slow. It's mainly used for data backups only. Both sides of magnetic disk is coated with magnetic oxide to store data. This is divided into multiple concentric circles called tracks, and tracks are further divided into sectors in which actually the data is stored. So whenever we are trying to search some data or go to some location, first it will move to the particular track in which the data is there. Then from that track it will find out the sector in which the data is stored. Due to higher reliability, magnetic disks come in two forms: floppy disk and hard disk. Right. Second is optical disk. Lasers are used to read and write to and from optical disk. So optical devices are reliable and widely used storage devices. For example, your CD-ROMs, DVD-ROMs, CD-DVD rewritable ROMs. Right. USB flash drives. These drives are removable, rewritable, and much smaller. Weight of approximately 30 grams or so. As compared to optical disks, these flash drives are much smaller, faster, durable, reliable, and have very large capacity. It can store much more data. For example, a CD-ROM can store how many? 700 to 800 MB of data. So we can have a pen drive to store 20 GB of data. Right? It will approximately weigh 30-40 grams or maximum 50 grams. Right? So connect to computer or laptop using USB port, universal serial bus port in our laptop and desktops. Fifth is mass storage devices. These are exceptional storage devices actually meant for some trillions of data. Let's see. Used for saving huge volume of data in a persistent way. It can store more than trillion bytes of data. Good media to store large databases of DBMS, right, database management systems. Some common examples are disk array, automated tapes, and CD-ROM jukebox.